Good evening, everyone. I welcome you all to the workshop on Introduction to Machine Learning by GDG GEU. Starting with my introduction, my name is Priyanshu Sharma. I am a fourth year BTech CSE student and currently serving as a machine learning lead in Google Developers Group, Graphic Era University. So this is our first workshop on machine learning, and in this we'll be covering basic things about machine learning, what machine learning is, what are the types, and more or less to that same thing. So let's start with what machine learning is. Machine learning is a subset of artificial intelligence that focus on building systems, and it can learn from data and improve over time. Basically, what machine learning is that machine learning is the methodology by which we can make a machine learn about something by a human commands or the data that we have input in the machine. And why we do that? To obtain some outcomes, some results that are desired by the user, and the user wants accuracy in that. So how does it do that? It uses statistical techniques and algorithms, which we will be studying further, and it identifies pattern and make decisions that are human like in behavior, and it predicts the outcomes based on that data. As in the diagram we can see that machine learning is a subset of AI and deep learning is a subset of machine learning. So we can say that machine under the artificial intelligence we have machine learning, and then we have deep learning. What deep learning is? Deep learning is the modern concept of machine learning after the evolution on algorithms and more technology demands, which has high advancements like big data and neural networks, also your algorithms. So now let's move on to evolution of machine learning. Evolution of machine learning started with the Turing test that was invented in 1950. I believe that most of us know what Turing test is because it is one of the major concepts that is covered in our syllabus for machine learning. What Turing test is, it was a test that was established by Alan Turing, a data scientist, and this test used to measure the machine and tell that how that if it is eligible to perform human like actions or behavior. In this test we had three major components. The first was the interrogator, second was the person, third was the machine. So what happened in that, in the setup, the interrogator would have asked questions to the human and then to the machine. If the Turing test was said to be passed if the answers given by the human and the machine were similar to each other. That way we could have predicted that yes, the machine is able to predict the outcomes as per the human intelligence, and if not, then the Turing test was failed and that machine could not have do the human like actions in performing. Then now coming on to first AI winter in 1973, here we see the boom in AI and the requirement and the need that was faced by the industry. In this, we had some basic machines that used to perform human actions, and those were the times that the AI was very booming and AI was very needed in the society. Coming on to the second AI winter, at this point we had a little halt in the AI because the technology was not that well advanced, and the features that were needed now for the human task were not very well furbished and not very well created at that time. So they had a little halt in developing those technology, but since 2012 to 2019 and nowadays we have seen the revolution in deep learning. We have neural networks, we have big data, and we have other advanced algorithms that are used to predict the outcomes very more with more accuracy, and the results are very well efficient, and also the user demands are fulfilled in a very efficient cost and with time management.
Now coming on to the types of ML. There we have categorized machine learning into three types, that is unsupervised, supervised and reinforcement. Anyone who has a basic idea about any of that? So yeah, Tarun or Samar, how would you describe what is a unsupervised machine learning? कोई machine कितना human type output देती है? Supervised ML works on labeled data. No, Himadri. Yeah, supervised, yes. Supervised does. Yeah, Shivang, right. Good, guys, good. Good to know that you have this basic concept here. So yeah, as everyone said, that unsupervised learning, we have the model that learns pattern and structures from data without the labeled answers or without any help from any supervisor, etc. For example, we are grouping similar customers in an online store based on their shopping habits, and that is also called as clustering. We'll be learning more about this keyword in further slides. Then next we have supervised learning. So in supervised learning, as you mentioned, that we have a supervisor or we have a label data. In this, we are provided with a data set, and on that data set, we predict the outcomes for the new data inputs. For example, like we are teaching a program to predict house prices by using the features of like what the house size is, where the house is located, or what the land cost is and previous times, and by that we can predict the new price or the new prices of other houses that are going to be there out for sale. The goal for supervised learning is to make prediction, and for unsupervised is to mainly make some groups. Then we come to reinforcement. Anyone who knows about reinforcement learning? Reinforcement, guys, come on. Anyone with reinforcement? Reward base. Yes, yes, yes. Somewhere. Yes, Keshav. Yes, Ishan. Yes, Tanush. Yes, feedback. Yes, that was a keyword. Feedback. So yeah, reinforcement learning. It is a learning where an agent learns by interacting with its environment and receiving rewards or a feedback on the basis of their actions. For example, we have a self-driving car, or let's take a very basic example. Like many of us have a pet dog in our home, and we teach him tricks in his very young days. So we give him treats, and that is a reward for the dog. And on that basis, we train him to perform some actions or some tricks. Then coming on to the bigger technology view, we have self-driving cars, and we make them learn by providing them a basic concept of to stay in lanes for not hitting the obstacles, and in return we give reward or feedback. That is mainly in the way of ratings, the car ratings that we have, and based on that we have the sale structure. Now let's look more at the detailed explanation for all of these. So firstly, we'll start with unsupervised learning. So we have a very cool flowchart diagram for it to be explained. Let's look at the flowchart. We can see that we have a scattered input data stream, that is the raw data, and we are required to categorize it into groups or similar fields of information, as you can see in the last step. So the first step is to analyze and interpret the input data using any specific algorithm. As we don't have any output, the previous output based on that same algorithm in unsupervised learning. So our goal is to specify algorithms that would predict us the result. Then after using the algorithms, we can see that we have our results. After the processing, we have different results. We'll learn more about the algorithms of unsupervised learning in the next few slides. So coming on to the unsupervised machine learning. You all can see the flowchart for supervised machine learning. Everything looks pretty same as the unsupervised, but here we have this one main structure in the algorithm, that is the supervisor or the training data set or the desired output. What happens here, we have a data set that contains information or many different pictures, images, or video clips, or any related information of our input data, and we give it to the algorithm that trains it for us, and it has some desired output on the desired input. After that, the algorithm works and it trains the data, which gives us the accurate result. The good thing about this procedure is that it helps in bringing us accurate result even for complex inputs, and we have a results and outputs for new input. Other than this, we have reinforcement machine learning. In reinforcement machine learning, we have our input data, we put it in an algorithm, any algorithm specified. Then we have a state of reward. In the environment, our agent is trained and we provide them a reward. For every reward, the ratings can be increased, and based on that, we have a results. So I hope that was clear for unsupervised, supervised, and reinforcement learning. There is some algorithms that we are gonna work on in the next few slides. Now let's look at the real world applications for machine learning. We have traffic forecast, spam filtering software, video surveillance, virtual personal assistant, online fraud detection, products feature, search engine result, social media, smart customer service. Is there any other application of ML that we use in daily life that you all can state? The most common machine learning: sentimental analysis, crypto, weather prediction, recommendation system. Something that you use very much, very often. ATS, yes, a good one. Computer vision for figuring out without helmet. Chatbot, yes. ChatGPT, AI, Google search, great. Smart attendance system, genre of movie, Gemini, Siri, good one. So yeah, basically everything in our daily life now, we have machine learning in every sector, and we use it a lot, and it has provided us so much ease to do our work, everything. So yeah, next slide we have machine learning algorithms. So at the machine learning algorithms, we get to know what different types of learning algorithms we have under different type of machine learning. So before starting this, we can let's see what these three keywords means: classification, regression, and clustering. So clustering we also heard in the previous slide. So yep, what classification is? The basic definition for classification is that it is a supervised learning technique where the model predicts a category or label for a data point. Let's take an example. Let's predict if an email is spam or not spam based on its content. So in that we can use classification, and it will give us if it is in the spam box or not in the spam box with the use of previous data sets. The key idea for it is to provide a discrete category output that could be yes or no, or in other forms of binary. Then we have regression. So what regression is? Regression is a supervised learning technique where the model predicts a continuous value on input data. For example, we are predicting the price of house based on its size, location, and other features. Then we have clustering. So what clustering means? It is an unsupervised learning technique where the model groups data point into clusters. What cluster is? Cluster is a group that is created of objects with similar features. For example, we have animal, a whole set of animals. In that we have amphibians, reptiles, mammals, etc. And we are grouping them all in a different cluster. So that one cluster is a group of similar genre of animal, and that is what clustering means. So the key idea for clustering is that there is no label that is provided. So the goal is to find patterns and make groups. For a better understanding, now let's come onto algorithms in depth. So as for now, we can't discuss every single one of them, but let's pick a few famous algorithms from both the supervised and unsupervised learning. So yeah, the first one is CNN. Has anyone heard about CNN before or ever used in a project? What type of projects we can make by CNN? Anything? What comes to your mind? Will we discuss the Python code for all? No, we are not discussing the Python code for every single one of them, but we have a machine learning model. So yeah, I'll be explaining that model. Cancer detection, yup. Dogs or cats for object detection, I guess. Pneumonia. Okay, any else? Attendance marking. Image recognition, kidney stone. Yeah, image analysis. No, sir, can you please elaborate how a spam mail is different from a genuine one? Speech recognition, okay. Car model detection, autonomous driving. Okay, yeah. So first we have a CNN, supervised machine learning algorithm, CNN, that stands for convolutional neural networks. So starting with this algorithms, we have a input data. As you all can see in the first step, we have a image. In this image, we can see a sunset. we have, I guess, a water body, we have a garden, a tree, and some sun rays. So yeah, what the input data is. The raw input to CNN, typically an image or anything that has a pixel value, for example, a 3D array or RGB images, we are providing it as a input. Then we are coming on to convolutional. What convolution is? Convolution is the process of applying small filters over the input data to detect specific patterns. In that image where we are applying the convolution, as you can see the white box over that image, and it has some edges. Those edges at those pixel points, that is our convolution. We have small filters, which can be also called as kernels, over our input data, and that detects the specific edges and the texture of the image that is converted into the feature map. So how convolution works: a filter slides over the image and it performs element wise multiplication with the image pixels. It produces a new matrix that is known as feature map. What feature map is? So the output that we get from the convolution operation, it highlights the important feature that it detects in the image. For example, multiple filters that were used in detecting the patterns in the image, it results in multiple feature maps. So for every different feature, we have a feature map, and these map, they show where the edges or the texture in the image occurs. As we, you all can, I hope you all know that in an image it is a pixel and there are small square boxes in a whole image. So those small boxes, they are used to become a pattern or describe a pattern that results in multiple feature maps. So for example, after applying these filters, our feature maps, they have highlighted the image of the edges of the image. Then we also can see that there is a ReLU. What ReLU is? ReLU stands for rectified linear unit. It is an activation function that introduces non-linearity to the network. So in images we don't always have straight lines. So that way we use ReLU. It replaces the negative values in the image with 0 and it only keeps the positive value. Then in the next step of feature maps, one feature map would have detected some more features of that particular image. In that particular image, we have some more features, and those features are multiplied more and more and more and more into the smallest unit, and we have a lot of feature maps for that same small part of the image. Then they are all connected with the fully connected layers. What this fully connected layer is, it is a dense layer where all the neurons or all the smallest element of feature maps, they are connected to the previous layers of output. So after that, all of the layers are merged together, and with that we can see it has described us that there is a boat at 0,4 coordinate, there is a house at 0.05 coordinate, then tree at 0.9 and cat at 0.01. So that is our output layer. With that output, this final result of CNN, and typically it is a probability for each class, and this CNN algorithm, it works again and again and again for every specific part of the image. With that we are able to predict what in the next image, what does it describe. Okay, so I forgot about the pooling. So pooling, it is an optional step. We don't necessarily apply it if it's not needed. It is a downsampling technique that reduces the size of feature maps to attain information that is very important to us. So what happens while pooling? We reduce our feature maps, and if the image is very small or the pixels are very blurred or teared apart, then we use pooling so that it does not create a lot of feature maps. Because after creating a lot of feature maps, we might miss out on any important information that would be required for other input data to predict our output. I hope this CNN was clear. Is there any question regarding CNN? Okay, fine, great. Then next we come on to decision trees. So yeah, decision trees is a very popular supervised machine learning algorithm, and it is one of the most simplest algorithm that everyone might have ever heard about. Anyone who has an idea about what decision tree is? Any simple information regarding this decision tree? Anyone? Fast. Yes, no, anything? Basically, it is a yes or no algorithm only. No? Okay, so yeah. Please explain it again. Say or no. Explain what CNN. Decision tree is prediction. It is kind of a prediction algorithm, but we mainly use it for the classification and the regression task. Decision tree is a supervised machine learning algorithm, and it works by splitting data into subset based on the feature values, and it creates a tree like structure that helps us in making prediction. So as in the left diagram, in the decision tree diagram, we have a blue box. Let's say we fill the blue box with do you have a car? We fill it with the option, with the question that do you have a car? And on the left and right nodes, we can write yes or no. Then these yes or no would define in the next blocks. In that we can have questions like what is the mileage, or is it new, or is it old. Then in similar ways, we have this tree like structure that works on our question, and after that question we have a result in the following nodes. So the data set, it contains both the inputs and the target output. Let's start with the root node first. So the top node of the tree, it is known as the root node. It makes the decision making process start. Then the algorithm that chooses the best feature to split the data based on criteria. It is it basically works on the concept of Gini index, the information gain or variance reduction. For this, we will have to keep a session on statistics and mathematics for machine learning, and that we can easily learn more about what Gini index or information gain for a decision tree is, and on that basis only it makes the predictions. So let's take another example. If you are predicting a product purchase, so the first split might be based on what the person's income is below 5,000 or above 5,000. So that comes in the yes or no. Then the branching out step, the third step, or we can also call it as the splitting step. In that, we divide the data into subset based on the feature that is chosen at the root. The feature that we choose at the root, we divide in the data into the following subset on that basis and in any other node. So the data set is split recursively again and again at each node based on different features until our subsets are homogeneous. What homogeneous means is that all data points in the subset have the same target value. Like is if everyone is yes at the end or everything is no at the end. So that is what at the last node happens. These are known as the decision nodes, the last nodes with the homogeneous answer. Then we can also create the random forest algorithm. What random forest algorithm is, you have known about the decision trees now. Is there anything that you can connect with random forest? How can you connect decision tree with random forest? Please tell us about linear regression. Okay, yes, now it is clear. Thank you. Bagging method? No. My question is, how can you relate random forest with the decision tree? Entropy. Ayushu, entropy and everything, we can have a different session, because after that it will be very long to know about all the graph and then what information gain is, what entropy is, the formulas. So yeah, what random forest is a mix up of a lot of decision trees all together. When we bring all the decision trees and we have interconnected nodes and everything, in that way we have a random forest. It becomes the tree, single tree like structure, it becomes a whole forest, and in that forest all the computation and the prediction works, and then we have the result in the form of yes or no's. Now moving on to k-means algorithm. K-means algorithm is a unsupervised machine learning algorithm. I guess you will all like it because it includes one of the very basic formula that we have used in our school time since class 10, and that is the Euclidean calculation formula. What K means is, it is a algorithm, and the main group is to group main goal is to group similar data points into clusters. So in the K means, it works by dividing data into K number of clusters. So that k, the k in the k means it stands for a variable, for an integer. On that basis, we divide the data into clusters. So in this following image, we can see that we have four different type of clusters: the yellow, red, blue, and green. Then that specifies that our k value is 4. In the input data, we have a data set that contains features, or also known as inputs, without any labeled output. There is no labeled output because it is an unsupervised machine learning algorithm. So yeah, for example, we are clustering people based on their spending habits. So the data set might contain features like age, income, spending on food, spending on entertainment, spending on shopping, on movies, etc. Then we choose the clusters. Either we can choose it or it is specified to us in the questions. After specifying the clusters, we will divide it into those number of clusters, those number of k values, and we can also mention that if it is a high value, a low value, or medium value on the basis of the grouping in the clusters. Then there is a concept called centroids. What centroid is? The algorithm, it randomly picks a point from the dataset as its initial cluster point, and that is known as the centroid. So centroid is basically as the center value for each cluster, around which we would create more different clusters. So like in this yellow dot, this big dot is our centroid. Here in the red cluster we have red dot, in the green we have green, and blue we have a blue center dark dot. That is a centroid. What our next step in this k-means algorithm is that we assign different data points to the closest centroid. For each data point, the algorithm assign it to the cluster with the nearest centroid using a Euclidean distance formula. In that distance formula, for example, we have this blue point and we have this centroid. Then we will calculate the distance by the Euclidean distance formula between these 2 points, and only the points that have the nearest distance with each other are kept together in one cluster. If we compare like this point, this yellow point, with this blue centroid, then the distance is very huge, but with the yellow point and the yellow centroid, the distance is nearest to it. That's why this yellow point is in the cluster for yellow cluster, and these blue points are in the cluster for blue cluster. So I hope that is clear now. And these steps are repeated again and again. For example, like in this initial step, this blue centroid, it had calculated its distance with this black point, and so it saw that the distance is nearest to it, so it came into its cluster. This does not happen in first step only, it iterates again and again. It's a recursive process, and after repeating it iteratively, in each iteration the cluster, it gets refined until the centroids stabilize. Then after a few iteration, the centroid stops moving and each the data point is assigned to its final cluster. So then when we have an image or anything, we put as an input, and it see that the distance is coming across among these distances, then it is grouped into that same cluster. I hope unsupervised this is also clear. The random forest algorithm combines the output of multiple and variation trees, use machine learning, independent forest is random, like KNN. Yep, like KNN. So I should consider that the centroid as a nucleus of an atom, and the cluster can be considered as the protons or neutrons. I guess let's not consider it as the protons or neutrons, but yes, we can consider it as a nucleus of an atom. That atom here in the diagram, I'll specify. See, let's say this blue dot, this dark blue dot is our nucleus, and this area in the boundary, the last with the last blue dots, that is our the last membrane or the outer layer of the cell. So that we can compare it as of an atom. Yeah. So great guys, we learned about 3 algorithms, that was CNN, decision trees, and k-means. Also a quick learning about random forest. Now let's come on to the machine learning libraries. Machine learning libraries and frameworks. So these are one of the most important feature that is used in the machine learning, specifically for data science, as we have to know about Python. With Python, we have some libraries and frameworks specified in the slide. First, we have NumPy. NumPy, it states for the numerical operation and the array manipulation of data. Then we have Pandas. Pandas is used for the data manipulation, analysis of the libraries, and it simplifies working with structured data. Then we have Matplot library. It is a plotting library for creating static, interactive, and animated visualizations. Usually, it consists of graphs and pie charts. Then we have scikit-learn. It is a simple and efficient tool for data mining and machine learning. Then one of the major library that is used as TensorFlow. It is the open source machine learning framework for building and training deep learning models. Then we have PyTorch. It is an open source deep learning framework which is known for dynamic computation, graphs, and flexibility. Last, we have SciPy. It is an open source library for mathematics, science, and engineering built on NumPy. Let's look a little into the websites for TensorFlow. Now we have TensorFlow. This is the import code for TensorFlow that you can use in your Python code for machine learning. Here this xtrain, ytrain, xtest, ytest, load data, xtrain 255. This basically specifies that we are using TensorFlow library for the training and test split of the data set. And from here we can know more about TensorFlow. Here we have all the TensorFlow libraries, all the functions, keras. If you want to know more about how everything deep into TensorFlow, learn about various functions or the values that are used in TensorFlow, you can go onto the website. You can also install them in your environment. Then we have Matplot library. Matplot library, it basically has been used for the plotting of graphs. Here we specify the array points in the graph. That is, like, here is a graph. We have 1 to 3 to 8, then we have 3 to 10, then we are plotting the values for at the x-axis for 1 8, then for y point we are plotting as 310, and that we get a linear graph. So this is how you can check more for matplotlib plotting for graphs and charts. Then we have scikit-learn. Scikit-learn is basically the open source library which provides us with the classification, regression, and clustering, dimensionality reduction, model selection, reprocessing of data. It helps in a lot of ways in the machine learning. Wait, let's look at the examples. So we'll go for decision trees. We did about decision trees right now. Here we have a 1D regression with decision tree. Decision trees is used to fit a sine curve with addition noisy observation. As a result, it learns local linear regression approximately the sine curve. Here we have specified our requirement, the points and the axis points. In that case, we have the graph for decision tree regression. This was more about the libraries. Now let's come on to the major part of today's session, that is machine learning model. So before starting, anyone who knows about what the steps were for machine learning model creation? Yes, Prakhar, what was the question? Anyone who knows a few steps that are involved in a model preparation? Has anyone worked on a model before? And what did you want to ask, Prakhar? Are you still there? Pre-processing, yes, there is a step pre-processing. Data cleaning, yes, there is a... no, Prakhar, you are not audible. Can you write in the chat box? I want to know, we should use TensorFlow only in Google Colab. Wait, Prakhar, I'll show you one thing after this session. Like during the machine learning model, I'll show one thing, in that we have everything. You just have to install TensorFlow in your command prompt and your system. And after, there is a software called as Anaconda Navigator. We have this software Anaconda Navigator. It has all the softwares that is required for machine learning, for data science, for model building. You will get everything in that, from Jupyter Lab to Jupyter Notebook. Yeah, you can also use VS Code, but I guess the The most preferable would be Anaconda. Define the problem, gather, right, I'll go. So there is any connection to it. I don't think so. If there is any connection with installing TensorFlow in your VS Code, and then so yeah, look here. Have this Anaconda navigator. It has everything that you require, all the softwares for everything that you want to create. For example, this is Jupyter Notebook. If I launch it from here, it will redirect me to the browser. So yeah, here I have the Jupyter Notebook, and here you can see some of the models that I've worked on, or everything, every file, and then I can access यहाँ से, and we can create our models. So yeah, now not wasting more time. Then we come on to the machine learning model process. So the machine learning model, it is a mathematical model that is trained on data to make predictions or decisions. We have a key steps that are: the first, we define the problem, that is also known as importing the problem statements. Then we collect the data. For collecting data, we have one of the major like one of the famous website, that is known as Kaggle. You can get a lot of data set of various information, everything from there. After collecting the data, we pre-process the data. We do multiple steps in it, like data cleaning. By data cleaning, we have that in our data set there are multiple fields that carry missing values, or they are not properly optimized. Then we pre-process that data. Then we select the accurate model from our end, that what model should be preferable for the type of result or the type of task that we have to perform. Then we train the model. After training the model, we evaluate the model. For evaluation, we have one major attribute, that is the accuracy. We test the accuracy if the model is accurate. Preferably model that gives the accuracy of above 85 to 87, it is considered as a good one. But you can also increase the accuracy by 95 to 97 and above. After that, we deploy the model on the server. We can also, there is a famous library that I forgot to mention, that is Streamlit. Streamlit helps you to bring the front end to the ML model. Like, you don't have to code for everything in the front end. It has a basic architecture, a whole defined architecture, and with that you can deploy the model and giving it a front end. Next, let's talk about a movie recommendation system using CNN. It is a very basic model, a very small model, and we have also learned about what CNN is. So we can see how CNN would work in this now. Now here is a guy. He is asking let me watch a movie. So we have a recommendation system. This recommendation system would, how will it work? It works on two major bases. That first is the content based filtering, and then it has collaborative filtering. What content based filtering is, like this young man, he has read something on the internet, or like famous example, you sometimes search something on Amazon shopping, that you want a camera, or you want a projector, or a jacket, or shoes, and then suddenly somehow Instagram is there and showing you all the reels or ads suggested to that type of item. That is the content based filtering. In this case, this user might have read anything about movies, or any articles he has read, or someone has recommended something about a movie or a genre, and with that the model, it filters the data and gives him the desired output on that genre. Then we have collaborative filtering. For example, let's say you and your best friend, you both have a similar taste, you both have same habits, that's why you are best friend. And on that similarity, you both can see that what the most common thing in between you guys are, and what genre is there in collaboration. And with that, the model would give you the result. I hope this overview was clear to everyone. Is there anything about this overview? Anything regarding this overview? Any step from recommendation system to genre? Anything about content based or collaborative based? In any model, which fitting is considered best, overfitting or underfitting? So, in the concept of overfitting and underfitting, the model the model that overfits the algorithm is also wrong, and that underfits it is also wrong. Your accurate model should not have that overfitting situation, neither the underfitting. Yeah, so here is the code. I hope my VS Code is visible to everyone. Here is the code for movie recommendation system. Starting with the first block, we are importing NumPy and pandas for our mathematical calculation that is required by the CNN. So we have defined NumPy as NP and pandas as PD. After that, we are providing is the data set with the of TMDB 5000 movies. It has the names of movies and then other credits. It has 5000 credits. What credit is? Credit is what the director or what the supporting cast or popularity overview, anything about the movie, all the attributes, and the movies has the names of different type of movies, approximately 5000. Here we have movies.head 2. In this, we are asking the model to show us what the first two rows of the movie dataset is. Then we can see that we have different columns of budget, genre, homepage, ID, keywords, the original language it is made in, the original title, the overview, a little description about the movie, then the popularity, how many people have watched it, the production companies, the countries, release date, revenue it has made, the runtime of the movie, spoken languages, status, tagline, title, the voting average, and the vote count. So we have so many columns about the movies, but and then we are merging the movies with the credits on title. For that, we are only selecting now the movie ID, the title, its overview, genre, keyword, cast, and crew. So this way we can see that in overview we might have some keywords like here in this in the second 22nd century a paraplegic marine. So marine could be a keyword. On that basis our model can genre could be one, like what the genre is, if it is action or if it is adventure or it is a comedy or a sci-fi, etc. Some people also like cast, like for example one of the actor Peter Parker, Ryan Reynolds, and this could be a cast. So some people would like that person's movie, and we can use cast as a option to train a model on. Then in the next line, we have movies dot drop now. What this drop now means? This drop now means like we learned about that there are values that are missing in rows. So what drop now does? It removes the missing values from the data set. Now coming on to the next part, let's go down. Let's see there. Now we have seen that movies.head. In movies.head, we can see the titles or the columns that we have merged before. We have it down here: movie ID, title, overview, genre, keywords, cast, and crew. Now we have shortlisted our data set into the preferable keywords. After those keywords, here we have collapse. What these collapse are doing, like in the data set we have the data set is not cleaned. Like if you can see in the genre we have so many brackets, then in keywords you have brackets, the cast you have brackets, these brackets and everything, it does not look good. So to simplify it, we use collapse, and with that we make it a little better to understand or to be presentable. Here we are now splitting the data. After splitting the data, we are dropping the columns for overview, genres, keywords, cast, and crew. After dropping these keywords, these columns, what we have now is movie ID, title, and tags. And now on this basis, we are gonna predict our result. Here, now we add scikit-learn matrices for pairwise. We import the cosine similarity. What cosine similarity vector does, it on a graph, it draws a vector, like we have a graph and it draws a vector. In that vector, it chooses the distances, like wait, I'll explain it on paints. Like imagine this is a graph and we have a specific one line like this. Here we have what was our columns. Our columns were now title, and tags. Okay, so now let's say that we are dividing them on the basis of title. Now on the basis of title, we will divide the movies. These are our data points. So the titles with the similar title or similar genre or anything, we will group them into one, like here, here, this one. So what this is basically our clusters. Cool. Then we draw a vector between all of them to connect the genres, that what genre could be fitted with what genre. Like some movie might have a genre as action plus thriller, or some movie might have sci-fi and adventure. So this way we can group our data. For example, now we have asked our recommendation system that we have a movie as Avatar. On that basis of cosine similarity, it will give us the prediction of different movies that could be as similar to Avatar. We have the suggestions as Apollo 18, Aliens vs Predator, Battle, Life Force, or Titan. So yeah, this was what a basic ML model looks like. Then this import pickle and everything, these are used next for the ये सब like स्ट्रीमलेट अगर करना हो, अगर तुमको इसको डिप्लॉय करना है कहीं पे, एक फ्रंट एंड देना है एक बेसिक, तो उस चीज़ के लिए तुम यूज़ कर सकते हो. तो ये था एक नॉर्मल CNN का. वी कैन ऑल्सो यूज फिलना इन प्लेस ऑफ ड्रॉपना. या वी कैन. एनी क्वेश्चंस रिगार्डिंग मॉडल नाउ? No questions? Okay, so I guess the project was also clear to everyone. Now in the next slide, we can see a roadmap to proficiency in machine learning. In this roadmap, we have a foundation. For the foundation basics, you should have known about a programming language. You should be proficient in one of the programming languages. It could be Java, Python, R language, etc. Anything else. Then you should have knowledge about basic probability and stats, the math that is used in machine learning. Then we have algorithms, like we have learned about supervised, unsupervised, reinforcement. There's some one other algorithm as semi-supervised. It's not much different than supervised. Then we have model evaluation and tuning, the cross validation technique and the model selection. This all is in the part of stats that you would know in next workshop that we would conduct. We have some advanced topic, that is NLPs, the deep learning computer visions. These are some important topics or important technology that are used in VRs, or you can also like chat GPT, chatbots, or और क्या कह सकते हैं हम, like more and less to that. Then we have tools and frameworks, some tools and frameworks or libraries like scikit-learn, TensorFlow, PyTorch, Pandas, NumPy, many more. Then project. The main and one of the crucial component for learning machine learning is project. If you will not work on projects or you will not use machine learning into projects, then it will be a waste of time. Only projects can bring you experience and more knowledge about all the libraries and how to function with machine learning. It could become complicated at one time, but if you keep it close and consistent, then it's gonna bring you benefits only. You have open source competitions, hackathons, or personal programs, personal projects, many else. Then what are the top career options after learning machine learning or being proficient into data science? We have first the one of the most heard profession, that is data scientist. Then we have ML engineer. Then we have ML architect. Then robotics engineer, AI system designer, then deep learning engineer. So yeah, I guess this was all clear to you.
So guys, wrapping up with this session, we'll be back with more exciting workshops over machine learning and AI in future. And I hope you all had a great learning time today. And here at GDG, we are very grateful to see you all being so enthusiastic and active throughout the whole session. So have a great time ahead and good night to all of you. Thank you.